All right, welcome. Today, the Fundamental Theorem of Calculus, Part 1. So, a big day. Let's begin with a statement of the theorem. So, suppose f is an antiderivative for a continuous function f on some interval a to b. And so what this really means is that f prime is f. Then you can evaluate definite integrals of little f by grabbing the antiderivative, capital F, plugging in b, and then subtracting off plugging in a. And this has some notation. Since it comes up so often, this is written as f of x evaluated from a to b. Okay, so plug in the top and then subtract off plugging in the bottom. All right, that's the fundamental theorem. I'll tell you in a little bit why it works, but let's go ahead and use it. This lets us do a ton of integrals really easily. So for instance, we can do the integral from, what did I want to do? 2 to 4 of x cubed dx. Well, the theorem says find an antiderivative for x cubed. So x cubed had to come from x to the fourth. And since the fourth comes down, we want to kill it. This is an antiderivative, 1/4 x to the fourth. And we evaluate it from 2 to 4. Which means, first of all, we change the x to a 4. And then we subtract off when we change the x to a 2. And so you can simplify that, but that's the answer. Okay. You can also do very generic integrals. For instance, the integral from 0 to b of x to the n dx. Now, if you're looking for an antiderivative, it meant it came from an n plus 1. And to kill that n plus 1, when you take the derivative, you need to divide out by it. You see, of course, this is for n, n can't be -1 here, because otherwise it'd be division by 0. And remember, for n equals to -1, the antiderivative was the log. But anyway, it's x to the n plus 1 all over n plus 1, evaluated from 0 to b. And so, what we get is 1 over n plus 1, b to the n plus 1, minus 1 over n plus 1, 0 to the n plus 1, which is, of course, 0, so no one writes this term. But anyway, very general formula now for that integral. One more example. Find the area of one arc of the sine function. In other words, what's the area under the curve of this? So here y is equal to the sine of x, and we're going from 0 to pi. So find the area of that. Well, this is just an integral, so the area is the integral from 0 to pi of the sine of x dx. All right, by the fundamental theorem, we need to find an antiderivative. So, who has derivative sine? Well, minus cosine does. So that's the antiderivative, and we evaluate from 0 to pi. So that means we plug in pi, then we subtract off, so minus minus, plugging in 0. So we get minus 1 plus 1 for a total of 2. So the area under one sort of arch of the sine function is 2. Anyway, that's the fundamental theorem. Enjoy!